Hi guys, guess who's back? Professor Ethan's back. So in this video, Professor Ethan's going to show you how to find the derivative of sine of x. So your sine of x graph looks like this. You set up 2 points. The height here is given by the numerator. The cross here is given by h. And your job is to find the gradient of this line. Take the limit as h tends to 0. It will then give you dy by dx. So take it away, Professor Ethan.
Okay.
So yeah, so this equals...
What you do, you have to do the... I forgot what this is called. What is it called?
Well,
again?
double angle thing. So you
Yeah.
can break this up, right?
Yeah, you have to double angle the
Yeah,
sine.
so break that up. So how do you break up that block?
Well, first, when you're double angling sine,
Yeah,
first it becomes sine, and then the first
Yeah.
thing, and then it becomes cos,
Yeah.
the second thing, which
Yeah.
is h,
yeah,
and then plus
yeah,
cos,
yeah,
the first thing, which is x,
yeah,
and then sine, the second thing,
Yeah.
which is h, and then
minus...
kinda red.
Oh, squeeze it in right at the end. Minus this block here,
sine
right?
x
Yeah,
over h.
yeah. And by the way, most of us can't remember this whole thing here, including myself. But Professor Ethan, being a true professor, he memorized it. Somehow he managed to memorize it. So you might have to look this up. But Professor Ethan memorized it. So come on then, take it away. Then what? Oh, let's move it over here.
Yeah.
More space. So dy by dx equals what?
So now you notice how there's like sine here and sine here, right?
Yeah,
Well, you move this block over here.
Yeah.
And then move this back.
okay, yeah. So you're switching this block with this whole block here.
Yeah.
So come on then, Professor Ethan. Oh, don't forget the limb.
Oh yeah.
And write it small as well, Professor, because we're going to run out of space. Okay,
And then you just put this,
yeah, cos of h,
and then minus
Yeah.
sine x,
yeah,
and plus cos x sine h,
brilliant, all over h.
all over h.
Yeah, and then let me create some space. And then what, Professor? So dy by dx equals what?
And then you like cut
Yeah.
in between here and change it to like a...
Yeah, so basically you've got one massive fraction here. You're going to break it up into 2 fractions, right?
Yep.
So it would be something like this. Okay, the 2 fractions. Yeah, write it small though. Hang on, Professor, you're going to run out of space, aren't you?
Oh yeah.
Yeah. So all you're doing is you're breaking up that massive fraction into 2 smaller fractions. Yeah. And then what, Professor?
This part I usually kind of forget.
Okay.
Here you have to factor out the sine.
Yeah.
And you factor out the cos.
Yeah. Cool.
Ah, shoot, I just forgot. So when you factor out the sine,
Yeah.
this will become sine x
Brilliant.
lim
Brilliant.
as h heads to 0
Yeah.
and cos h minus 1
Brilliant.
over h.
Brilliant.
And the other side, since there's not really sine here, this thing is just like one massive block.
Yeah.
You just factor out cos.
Yeah, because that cos there is like a constant. You can take it out. Yeah. Yeah, the reason why it's a constant is because h is moving. So h is moving about. X has nothing to do with h. So
Yeah.
it is like a constant, so you can take it out. So it's basically this block, multiply with this block, and then you've got this block, multiply with this block. Now, what is this? What's the limit of this? This is a famous limit. What is it?
You might find this on his channel somewhere.
Yeah.
But this limit actually equals 0.
Yeah. And what?
It's the
Yeah.
same as 1 minus cos x over x,
Yeah, and
which equals 0.
and Professor Ethan, being a true professor, if you look at his whiteboard, look at that. It's right there. It equals 0. Okay, and then later on we're going to make use of this.
Yeah.
So back to this thing. So now what does that block become?
Well, this block is the same as sine x
Yeah.
over x,
Yeah.
which equals 1.
Yeah, when you take the
So,
limit, yeah.
This equals 1.
Yeah, so what is overall what does it become?
Well, 0 times sine x is just 0.
Yeah.
And 1 times cos x is
Yeah.
cos x.
So when you differentiate sine of x, it becomes cos of x.
Yeah.
So that's your final answer. Thanks, Professor Ethan.
No problem.